In this video, we're going to look at vertical asymptotes. Vertical asymptotes are vertical lines that are values where your domain is undefined, and as we approach that undefined value on the x-axis, your limiting values are either positive or negative infinity. So taking a look at this graph that we have here, we can see that this graph has an asymptote here at x equal -3, so our vertical asymptote is x equal -3. So if we look at those limiting values, so if we look at the limit as x approaches -3 from the positive side, so we would be looking right here, that is going up forever, so we would say that limit is positive infinity. Looking at the limit as x approaches -3, left-hand limit, so from the negative side, this one we're going down forever, so this is negative infinity. So this function is undefined at -3, and also we're approaching these values of positive and negative infinity at those limits. A second example of this, here's another graph. So this graph appears to have two vertical asymptotes. We've got one here at x equal -3 again. And then we're going to have a second one over here, x equal 2. So if we look at the limiting values up here, the limit as x approaches -3 from the right. So on the right side, we're going up forever, so this one is positive infinity. We look at the limit as x approaches -3 from the left-hand side. Here we're going down, so this is going to be negative infinity. At x equals 2, my left-hand limit is going to positive infinity. The right-hand limit is going to positive infinity. So here we can just say the limit as x approaches 2 of f of x is positive infinity, since it's positive infinity on both sides. So we want to be able to look at a graph and sort of find the asymptotes by looking at the graph, but also from an equation. So we're going to look at a couple of options there. Most of our functions that have vertical asymptotes for right now are going to be rational functions. So a rational function is any function that can be written as a fraction of two polynomials. So something like f of x equals maybe x squared over x minus 2. One of the keys to a rational function is that you have a variable in the denominator. In order to find the vertical asymptotes from these rational functions, we want to find values that make the denominator 0, but not also the numerator. So we'll look at some examples here. In our first example here, we have the rational function 4x minus 3 over x. So remember, our first step is to set our denominator equal to 0. So x equals 0. We don't even have to solve that easily enough. We want to check, does the 0 plugged into the numerator cause our numerator to be 0 also? In this case, that does not. So if we do 4 times 0 minus 3, that does not equal 0. So that tells us then that x equals 0 is our vertical asymptote. So we have a vertical asymptote at x equals 0. We can also take a look at this graphically. So if we look on the graphing calculator, all right, so if we take a look at this graph, we can see here that there does appear to be an asymptote here at 0, and to the left, my graph is going up forever. To the right, my graph is going down forever. So my limits appear to be approaching positive and negative infinity. We can also double check that it is exactly at 0 by doing second trace value, x equals 0, y equals nothing. So my value is my function is undefined at the value of 0, and from the graph we can see that those limits are approaching positive or negative infinity. So we can kind of use the graphing calculator to double check our asymptote, or you can graph it there and start that way. So looking at a second example, here we have x plus 3 over x squared minus 9. So we're going to, again, start with setting that denominator equal to 0. So x squared minus 9 equals 0. So x squared equals 9. Remember, this is going to give us x equals plus or minus 3. So I'm going to check that. So if we plug in -3, -3 plus 3 does equal 0. So that's going to tell me that x equals -3 is not a vertical asymptote. If we plug in +3 plus 3 does not equal 0. So that tells us that x equals +3 is a vertical asymptote. So I have a vertical asymptote at x equals 3. Taking a look at this graph, here we can see that there appears to be an asymptote over here at the value of 3. So again, I'm going to double check second trace value at x equals 3, y equals nothing, so it's undefined there. And to the left and right of 3, we are approaching positive or negative infinity. Remember when we solved our denominator, we got -3. If I plug in x equals -3, I get y equals nothing again, which means it's undefined there. So this graph has an asymptote here at x equal -3, and then over here, or x equals +3, and then over here at -3, there would technically be a hole there. All right, so we've got one more example. Here we have 1 over x squared plus 1. So I'm going to take that denominator, set it equal to 0. X squared plus 1 equals 0. So I get x squared equals -1. Remember, when we solve that, we're going to get imaginary numbers. So all I need to know here is that this is no real solution. Asymptotes have to be real numbers, so no real solution. Therefore, this graph has no vertical asymptotes. So taking a look at this graph, we can see that there's no place where this graph is approaching positive or negative infinity, so it confirms for us that there are no vertical asymptotes.